Hi, I'm Capped Out. This is a recording of my Eve Vegas talk, RESTful CREST. So who was I? Between 2010 and 2012, I was CCP Zero Gravitas. You may have seen me on Tranquility flying Guardian in CCP dev fleets. You may have shot at me, you may have blown up my Guardian, you may have podded me, and you may have my frozen corpse in your hangar. So what did I do at CCP? So I worked with Team Cobra Kai, and the main thing I did was build the CREST. I also helped work on the single sign-on service. And the goal for the CREST was to make a read-write API to access the Eve cluster. There was already an existing API and it's still used, but it's a read-only API. And the reason for that is the current API provides data from Eve's database. And so if you were to make that API read-write, then you'd be writing to the database. The problem with that is the actual definitive version of the Eve universe, when Eve is running, is inside the Eve servers. So if you updated the database data, you could potentially end up with a situation where the data in the server's memory was different to the data in the database, and those inconsistencies would be difficult to fix. So really, the way you have to build a read-write API for Eve Online is you have to access the live running servers directly, and that's what we did with CREST. So while the original goals for CREST were to provide APIs for alternative clients that you might want to write on the web or on a mobile device, for example, while we were developing the CREST, it became clear that we should be using it for the Eve Dust link, because it turned out it was difficult to make Dust use the Python networking layer from the Eve client. And so as we were already building the CREST, the first application for the CREST became linking together Eve and Dust, and so the first client became the PS3. And so we worked on that. We exposed a number of APIs that were used by Dust to create the Eve Dust link, and it worked. We linked the two game universes using CREST. We stood on the deck of our carrier and we declared mission accomplished while the orbital bombardments rained down. So for a while, that was kind of the end of the story with CREST, although we'd initially planned to use it for kind of web clients and mobile clients. We ended up using it mostly for Dust for a couple of years. So why am I talking about it now? Because finally, the public CREST is live. The third-party single sign-on service is available, so you can go to the SSO, you can go to the developer website, you can register your application with CREST, you can get tokens, you can register yourself as a developer, you can register your application, and by doing so, that means that you can then start using the authenticated CREST APIs. So the public CREST data provides things like histories of wars in Eve and other publicly available data that you might want to use in your application. But once you have authenticated CREST access, you can act on behalf of a character in the Eve universe, and you can get access to the data that that character has that it's authorized that application to see. And so once you can do that, you can start seeing characters' private data like their skills, their contacts, and you can start updating it because the CREST allows you to write back to the Eve servers as well as reading from them. So we're right at the start of the point at which people start writing the clients. We'd always hoped that people would write with the CREST. Clients for the web and clients for mobile applications that allow you to access your character's Eve data when you're outside of the game. So you might want to build an application that allows you to prepare for a game, prepare for a battle, and then once you're back home and you can use the Eve client, you might log on with the Eve client and actually start flying in space. So because we end up with these third-party clients, what we're building is a development ecosystem, and that can be difficult to manage, because when we were building Eve and Dust and we were linking them together with CREST, although we had a client-server application and we had an API between them, all the parts of that system were being built by CCP. So ultimately, you could phone someone in CCP, you could find out who was working on the client, and you could say, hey, I'm changing the API, and it might not be compatible with the Dust client, and you might want to check that it works or make a change based on the changes we've made to the API. Once you have a third-party development ecosystem, that's not possible. All the people who are working on clients are not working for the same people who are working on servers. It's not always possible to contact absolutely everyone who might be affected by a change, and so you want to actually build the API in a way that allows applications to continue to work even as the API changes, without having to get in touch with absolutely everyone who might be building an application. And there are RESTful features of CREST that allow you to do that I'm going to talk about today. So when you look at the CREST for the first time, it looks a lot like Eve API, right? You make requests to the API. Here I'm using curl, and you get back a bunch of data. And the bunch of data is, in this case, in JSON format. So initially, the biggest change from the old API is that it's JSON instead of XML. So you might have heard some people talk about the Eve XML API and the Eve JSON API, but really JSON and XML are formats. You could easily you could format the response from a CREST API as XML, and then they look very much like the old Eve API. So why are they different? The differences are actually under the hood, and a lot of the differences are about knowing that if we make a request today, we can make a request tomorrow and it will still work. And if the Eve API changes in the meantime, there are things we can do to allow our application to continue to work, or to alert the users of our application in cases where the API changes in ways that makes it incompatible. So to look at some of the real differences between the CREST and the Eve API, we need to start looking at the metadata, the headers, rather than the data itself. So here's the same request that I just showed you, except I'm passing the -v option to curl, which means be verbose, and I've deleted the body from the output. So you're only seeing the headers here. And there's a bunch of interesting stuff here. So first of all, our request succeeded. We got 200 HTTP code back from the CREST, which is nice. The next one's interesting as well. The request is being served by Nginx. It's actually being served by Nginx on Linux. And one of the things that's kind of cool about the CREST is it's the first part of the Eve infrastructure that uses Linux servers as well as Microsoft technology. And then there's a bunch of headers which talk about caching, and this is because the CREST is a real web API, right? It exposes all of its metadata, all of its caching information via headers using standard headers, which means that all of the web infrastructure between the client making the request and the Eve servers can look at those headers and reason about them and allow that information to inform their caching decisions, and that allows them to reduce the load on the Eve servers and to also provide better performance for the clients as well. So for example, if you were making this request from a web browser, your web browser would have a cache, so it would look at these headers and figure out, do I actually need to make another request here, or can I just serve back the cache data and therefore return it much more quickly without using any network traffic? And then you might have some other caches in the middle at your ISP or somewhere on the internet, and then there is definitely a caching server in front of the Eve game servers. It's the Nginx server that we're using for caching again there, and that allows us to serve many CREST requests to many clients without putting much load on the Eve servers. So we don't want to add time dilation and extra load to the servers by making CREST requests. So we cache a lot of stuff in the Nginx layer, and there are some blog posts on my blog which talk about how that stuff works. So some of the headers allow the request to be more performant and more scalable, allow the CREST to scale, but some of them help us with this kind of forwards and backwards compatibility and help us reason about the dependencies of our application, and they help us to build this situation where we can make a client and it will continue to work in the face of changes, or it will know if it becomes incompatible due to some changes. So the most important header from that perspective is the content type header. So you can see a content type with this request of application/vnd.ccp.eve.api-version3 plus JSON. And what that means is that there's a representation here that has been defined by the CREST, and it has a name, and when you get that representation with that name, you can rely on the structure of the request. So if you get a vnd.ccp.eve.api-3 today and you get one tomorrow, you can rely on the structure of that thing being the same. If it's got a name and it's got a date and it's got a character in that API representation today, then it will have those three things tomorrow, and that means your application can rely on it. If it gets back a representation it's expecting, it knows, without having to check through all of the JSON kind of name value pairs, it knows what it can expect because it knows what the structure of that representation is. And so what we're going to do here is we're going to use representations, and representations are the RE of REST, to allow our applications to be more resilient and to depend on only what they need to depend on. And what we're trying to avoid is dev posts like this. There's a fairly decent number of changes, one of which is backwards incompatible. Since these changes introduce backwards incompatibility and potentially break some people's applications, we do ask that you let others know as much as possible and share this news around, right? So what this is, this dev post is an appeal to application developers to check their stuff, right? It requires out-of-bounds data. It requires a blog post to be read by application developers or read by an application developer who contacts another application developer to know about some backwards incompatibility. And what we're trying to do with CREST is push this into the metadata, push this into the requests and responses themselves by using headers and making the API RESTful, so that instead of developers having to tell each other that stuff has changed, the applications themselves can see that something has changed and they can reason about whether they can still work or not. So we want to avoid this, and there are really only three things you have to do to make your application resilient in the face of CREST API changes. So the first one is that you should always specify representations when you make a CREST request. So you can make a CREST request without specifying this is the accept type, this is the representation that I would like back. If you make a request like that, you'll get back the most up-to-date representation, and that allows you to kind of quickly make requests and develop your application and hack around when you're kind of developing and you're not relying on that request being the same tomorrow. But when you are relying on that request to be the same, you are relying on the particular structure of data. Once you've started building your application, you've started adding logic that says pull the name out of this representation, pull the character out of this representation. Once you've got that logic in your application, and once you've started distributing that application to other people, then you should really always specify which representation you're expecting via the accept header. And that's not a lot of work. The thing that's even less work is that you should ignore any extra data. So as the CREST APIs grow, a lot of the changes to the APIs will just be adding new stuff to existing representations, right? So one day you might get a name and a date and a character, and the next day you might get a name, a date, a character, and a corporation, right? And your application will still work in the face of that new corporation value in the representation, as long as it just ignores it. So what you shouldn't do is specify a representation via the accept header, and then when you get it back, check that the representation has the three values you're expecting and no more. You don't need to check that the three values exist, because you know if the CREST gives you back a representation that conforms to the structure that is of the name that you were requesting, then it will have the data in that you had before, and you shouldn't go through and say check it's got nothing else there, because the API will often be extended by growing existing representations, and in those cases clients can just ignore the extra data and continue to work. So you basically get some forwards compatibility for free just by ignoring extra data in representations that you are requesting. So here is that same curl request again, except it's using the -h flag to provide the accept header. So it's saying I want an application VND CCP Eve API version 3 from this particular URL. And you can see we get the same data back, because previously if we didn't make that accept header explicit, what would happen is we'd just get the most up-to-date representation, which is what we're asking for here. So everything's the same, but because we're specifying we want an API version 3 representation, if tomorrow an API version 4 representation was added to this resource, then our application would request the old one, and newer applications could request the new one. And maybe those two representations would be served by the API for a period of time, then maybe one might become deprecated, and then eventually the -3 version might not be supported. So because of that, rule number 2 is you should always check the headers and return codes when you make requests. So CCP will add, the CREST will add an X-Deprecated header if the representation will no longer be supported in the future, right? So in the example where there's an API version 3 and an API version 4, hopefully in order to minimize the disturbance to clients, what would happen is for a period of time, both version 3 and version 4 would be supported and could be returned by the CREST, but version 3 would have this X-Deprecated header added to it. And if your application sees that X-Deprecated header, it should alert users. It should pop up a dialog or do something that says, hey, this version of this client may not be supported in the near future. You may need to reach out to the developer and find out if there's a new version, or ask them to update it if there isn't a new version already. And then sometime later, once version 3 is completely deprecated, then the CREST will return a 406 status code to say, I don't know what you're talking about. And it will return the 406 whether you ask for a representation which is no longer supported, or you just ask for a representation the CREST doesn't know about. If you get the name wrong, you'll get a 406. If you ask for a representation which is no longer supported, you'll get a 406. And in that case, you should alert your user. You should say, I'm making a request to the CREST. It used to work. Now it doesn't work. You should get an updated version of your application. So the final rule is you should follow hyperlinks. So the only URI that you should ever pass to your application should be the API route. And then you should find the resources you need from that API route by following the hyperlinks. So you may have noticed in the requests I made earlier, a lot of the data that's coming back in the API route was just hyperlinks to other things, right? So you have a hyperlink to the characters, a hyperlink to the corporations, a hyperlink to the wars, a hyperlink to all of the other collections of resources within the EVE universe. And that allows you to just request the route and then find the hyperlink to the next resource you need, and you just follow that as if you were a web browser, right? So in the web world, you request a web page, the web page has a bunch of links, you click on a link, and then you ask for the next page. And the CREST is a hypermedia API. It also has hyperlinked representations to link together all of the resources that make up the EVE universe. And so you may wonder what use this is. Well, the biggest use is that it means that you don't end up with logic in your applications that build URIs based on some knowledge of how the scheme works on the EVE servers, right? So you shouldn't be getting a URI and going, I've got some prefix, I've got some crest.eveonline.com/users/ and then you're slapping on a user ID at the end. You shouldn't be building URIs on the client. You should just be getting URIs sent back in representations and then following those links, making requests to those URIs that you've been given to get your next resource. And that means that you're not making your application brittle by having it rely on particular clever out-of-bound data about how to create URIs. And it means that if a resource gets moved to a different place, if the URI scheme changes in the CREST, then your application will continue to work if all it's doing is following hyperlinks. But if it has logic internally for constructing URIs and the URI schema changes, then it will break your application. So again, it's about decoupling your application from the details of the CREST and about making it rely on as little as possible, so that as the CREST changes, there are a number of changes that can be made to the CREST, like adding data to representations or changing URI schemas that won't break your application. So if you follow those three links, those three rules, then you end up with a as resilient as possible of a CREST application. Your CREST application will depend on the fewest representation types. The CREST might have hundreds or maybe even thousands of different representations to different resources, but your application isn't depending on the entire API. It's only depending on maybe the 3 or 4 or 10 representations that it actually uses. And every time it makes a request, it says, I depend on this particular version of this resource, and you need to give it to me for my application to work. So your application is constantly letting the API know what it depends on as it makes requests, instead of just depending on like the CREST as of last week, because the CREST as of last week may be different from the CREST today, but that may be okay. It may be that your application still works, and by having your application explicitly tell the CREST what its dependencies are, then it depends on a small subset of the API instead of a particular version of the entire API. You also, by ignoring the extra data, depend on the fewest attributes possible, right? You're not getting a representation back and looking at all of the values in that representation. You're just looking for the ones that you care about, and often that's just getting a representation, finding a particular hyperlink and following that hyperlink. So in many cases you're only actually depending on a single value in the JSON returned, and that means that as the API is built and as the number of hyperlinks from a particular representation grow, it doesn't matter. Your application will continue to work. You're not depending on the entirety of that representation. You're only depending on a small subset of that representation. And also you depend on a single URI. You only give the API route to your application and then you follow hyperlinks from there. And one thing you should do is to make that URI user configurable, because then you can, for example, have an application that works against the production version of the CREST, and then a new version of the CREST might be made available on a test server. If your user can then update the root API that your application is using, then it can go and start from the test server route and everything will work. It will make that first request for the route from the test server. All of the hyperlinks in the returned representation will link to resources in the test server, and then your application will just be working against the test server. So then your user can try your application out on the new test server and they can let you know if something breaks. So you're allowing, by letting people provide a URI as the root and only using that URI and not building other URIs within your application, it allows your users to kind of help you out by testing your application against new test servers. And by telling your users when resources are deprecated or return 406, your users can let you know when CREST changes might break your application. So you should check headers, you should check return codes, you should alert users when you get an X-Deprecated or a 406 back, and you should make the root URI configurable so your users can go and test your applications against test servers. And if every CREST app from the start does those three things, then the CREST ecosystem will be in a really good place, right? Because CCP will be able to update its API and know that applications are doing the right thing to find out if they're still going to work, and they're going to be alerting users if they break, and it's going to make it much easier for CCP to change the CREST API, and it's going to be much easier for you to build applications and not have them break and not be brittle and kind of dependent on details of the API like URI formats. Instead, they are only dependent on the things they have to depend on, and so therefore they're much less likely to break in the face of changes to the CREST. So if everybody does that, then the CREST is going to be in a great place for the years to come. I really hope that that's what everybody goes and does. But there's more. So the CREST is a fully self-describing API. Every resource in the CREST, you can make an options request to that URI, and as well as returning the verbs that can be applied to that resource, so put, post, delete, for example, it also returns a list of all of the representations that can be used to describe that resource, and it returns schema data for all of those representations. And it's not in a standard format, but this facility is incredibly powerful. You could, for example, use that to auto-generate documentation. So I've been talking about representations in this talk, and one of the things you might be asking is, well, how do I find out what representations are available, and how do I find out what the names and values in those representations actually represent? And all of that is available via the CREST being self-describing, and so you could imagine building an application that just finds all the resources, makes options requests to all the resources, and auto-generates documentations from the CREST API itself. And that's something that I did when I was at CCP. It's something that Fox4 has done at CCP, but the cool thing is, because the CREST is self-describing, it's also something you can do as a third party. So if you don't like one particular format of the documentation, you can go and build your own. Other interesting things you could do is you can build schema checking and linting tools. Because the CREST describes itself, you can go and look at that schema and you can do comparisons and linting operations on that schema. So for example, you could write a tool which takes the schema data returned by options requests, and you could do that on Monday, and then on Tuesday you could make the same requests, and then you can compare the two schemas that you got, and you can make sure that, for example, that the only changes that are being made to representations with the same name are additive, right? So you can actually build a tool that makes sure that none of the things that used to exist in a representation are deleted. CCP are going to try and make sure that never happens, but obviously sometimes mistakes are made. You could build a tool that checked that didn't happen for any version of the CREST. You could also build a tool which takes the schema data returned by the options request and turns it into a standard format. So you can write a tool which goes and gets that schema data, generates a JSON schema, for example, and then that would let you use a bunch of tools to generate client APIs from the CREST automatically. So you could imagine a new version of the CREST comes out, you run your tool, it generates the JSON schema, and then use the JSON schema to generate some client library, and now you've automatically got an updated client library for whatever language you happen to use and want to use for your application, just by pulling that information straight out of the API. And it would also potentially allow the kind of holy grail of kind of RESTful APIs, which is the general purpose client. So you could imagine writing a client which goes to the API root, performs an options request on it, finds out what the schema is, finds out which parts of the API can be updated via a put request, and in those instances it could create a form which is populated by the current data. You could update, and then you could submit to the API to allow you to update data inside EVE Online using a general purpose client. And this might be a really valuable development tool, because you could imagine having an EVE client open, you're looking at the EVE client, you've got your general purpose client open, and you're playing with a new API to see, when I change the data via the CREST, what happens in the EVE client. Are the two things linked up? Are they working properly? It might make it a really useful debugging tool. So there are a few examples which I developed while I was at CCP, which are still available on GitHub, and they still mostly work. The CREST Explorer JS is a kind of general purpose client, sort of, which goes to the API root and follows hyperlinks. And its original goal was just to make sure that the API was like fully linked, that it was fully connected, and that you could get to everywhere from the API root. So that was its original purpose. It's still a useful client. It's not really a great example because it doesn't do the it doesn't ask for representations. So a better client to look at as an example is Contact.js, which is a JavaScript application for reading and updating contacts of a particular character in EVE Online, and that does absolutely everything I talked about today. So it starts from the API root, it requests representations, I'm not sure it actually alerts users in the case of X-Deprecated and 406 results back from the API, but I will update it to make sure it does that. So I'll make sure that by the time the CREST is available for people to write applications, that Contact.js is a really good example application that you can look at to find out how to write these applications in this kind of RESTful way that I've been talking about. Both of the applications are open source. They're dual licensed MIT or GPL, so you can go and grab them and fork them and build your own private application, or you can share what you make with the rest of the world. They're RESTful, they do everything that I've talked about today. They also provide examples of how to do authentication via the SSO using OAuth 2, and they do that in a secure way. So there's CSRF protection built into that. So they demonstrate how to use the CREST both RESTfully and securely. And so if you're going to start building a CREST app, then I encourage you to use one or both of those applications as examples. And I'm here to help. So I comment in our EVE Tech, I read Reddit, I read the forums and I comment there. I would be in #EveDev if I wasn't banned for some reason. So if any of you know how to unban me, my IRC name is Jim Perbrick. And I'm also going to be working with CCP, so I'm talking to Fox4, I'm looking at the CREST API as it currently is. I'm giving feedback to Fox4 and suggesting areas where things could be made more RESTful, and some of the features that I've talked about today have, a few bits of rust on them that need knocking off. But I'm going to be working with Fox4 to make sure that by the time the CREST is released very shortly, it will have kind of all that rust knocked off, and it will be able to do all the RESTful things that I've been talking about today. So I really look forward to seeing what you build with the CREST over the next decade. I look forward to seeing all the new doors that are opened up into New Eden with the CREST. So hopefully I'll also see you in space. You can generally find me in Josametto fighting for the Blue Republic. I also fly in RVB Ganked and Spectre Fleet, NPSI fleets, and I'm always easy to kill because I'm always capped out. Thanks.